All right, guys, so what we're doing today, we are actually starting chapter 4. Now, what we did before Thanksgiving break was also called chapter 4, but that was out of a different textbook. So it was the textbooks before the ones that all this stuff, the information or the material we're covering now is in. So it's the one before it. But if you have not turned those assignments in from the 3 worksheets that we had for that chapter 4 over matrices, you can still turn them in before the end of essentially Christmas break, the end of the semester. 3. So chapter 4 test, the test over this will be the last test we have for this semester. So we will be testing over this chapter 4. Now, chapter 4 for this year, what we're covering, finishing up the semester with, is polynomial functions. Now, we've actually worked with polynomial functions, quadratics, all of chapter 3. Those quadratics are a polynomial function. So now we're going beyond that. So we're going for polynomial, these equations with degree 3 or greater. 2 is also included. But we're going to look at degree 3, our cubics, our quartics, our quintics. We're going up in degree. And finding the solutions that make these equations true. So, recall that a monomial is a number, a variable, or product of numbers. So it's a part of the expression. A polynomial is a monomial or sum of these monomial terms. And we have some different names for them and degrees. Now, a constant, we consider it a constant function if it's just a number. F of x equals a number. Its degree is 0. Our next one that we have is a type of degree 1. If the degree is 1, it's linear. It's equation of a line. So 5x minus 7 would be linear. Quadratic is going to be degree 2. So 2x squared plus x minus 9. Now we can differentiate between the two because linear, 5x, the biggest exponent attached to a variable is 1, so the degree is 1, it's linear. In our 2x squared plus x minus 9, x squared is the variable with the biggest exponent, so the degree is 2, telling us it is a quadratic. Our next one is cubic, telling us that the degree is 3. When the degree is 3, it's a cubic function. So we have our x to the third minus x squared plus 3x would be cubic. And lastly, in the list that they gave us is quartic. It's a degree 4. So the variable with the biggest exponent is x to the fourth. Questions on any of those so far? Two main things to kind of go over. First, standard form. A polynomial function is considered to be in standard form when the order of the exponents is in decreasing order, writing the polynomial in order of decreasing degree from highest to lowest. So whichever variable has the biggest exponent would go first and then decrease all the way to our constant term, our term without a variable. Leading coefficient is the number in front of the variable with the highest power. The number in front of each variable is a coefficient, but the leading coefficient is the number in front of the variable with the biggest exponent. Because we call it leading coefficient, because according to standard form, the variable with the biggest degree is always going to be first. So its coefficient would be the number in front of it, starting the equation off. But before we get into writing it and defining it, we want to know what a polynomial is. For us to be able to identify or determine what a polynomial function is. And I find it easiest to be able to tell what it's not, what it does not contain. The first thing we say that the exponents aren't negative. We cannot have a negative exponent attached to a variable. I can have a negative exponent attached to a number. We cannot have a negative exponent attached to a variable. So we cannot have x to the negative second power. This will not be considered a polynomial function. We could have 2 to the negative 1/2 power. That's fine. But we cannot have a negative exponent attached to a variable. Exponents attached to variables aren't fractions. We cannot have x to the 1/2 power. I can have 2 to the 1/2 power. That's perfectly fine. But we cannot have a fractional exponents attached to these variables. So if we have x to the negative 2 or x to the 1/2, these are not rational or polynomial equations. Bless you. Our third is exponents aren't variables. I cannot have x to the y. Or 2 to the x. We can't have a variable to a variable power or a number to a variable power. Because 2 to the x would not be considered a polynomial function. That'd be considered an exponential function. Because again, we're wanting to make sure that these are considered polynomials. So if the exponents attached to variables are negative, it's not polynomial. If exponents are fractional, we have a variable to a fractional exponent, not a polynomial. If we have an exponent that's a variable, it's not going to be considered a polynomial function. Variables aren't inside a radical. We cannot have a variable inside the radical. So we can't have the square root of x. I can't have the cubed root of x, the fourth root of x, fifth root of x. It doesn't matter what the root. If a variable is inside a radical, it is not a polynomial function. It would actually be a radical. Next one is that we cannot have two variables being multiplied together. Can't have two variables being multiplied together. It's still an equation, but it's not a polynomial. And lastly, we can't have a variable in the bottom of a fraction. Questions on any of this so far? All right. We're ready to move on. We're good with all these here. All right. So these first few that we're going to look at. One, we want to determine whether or not it's a polynomial function. If it is a polynomial function, we want to make sure it's written in standard form, state its degree, type, and leading coefficient. So if we look at A, f of x equals negative 2x to the third plus 5x plus 8. So when we look at this here, I would go back and check and make sure, do we see any of these here? Do we have a negative exponent? No. Do we have any exponents attached to variables that are fractions? No. Do we have exponents that are variables? No. Do we have variables inside a radical? No. Do we have two variables being multiplied together? Do we have a variable in the bottom of a fraction? So can we say that a is a polynomial function? Yes. So it is a polynomial function. So since it is, we need to make sure it's written in standard form. Well, standard form, so the variable with the biggest exponent would be first, which would be 2x to the third power, yes? Since x to the third is the biggest, the next term would be x squared. X to the second power. Well, there's not one, so we don't list it. Can we go x to the first power or just x? Which would be our 5x, and then our constant term. So for us here, it's already written in standard form. If it's not, we got to rewrite it so that we have the biggest exponent first, followed by second biggest and decreasing in power. Now the degree. So the degree of a polynomial function is the biggest variable attached, or biggest exponent attached to a variable, which would be what? 3. So the degree for this is 3. Now the type. The degree tells us what type it is. Since it's a degree 3, this would be a cubic. And luckily it is listed there on the first page. Degree 3 would be cubic. So we have the degree, we have the type. Now all we're missing is the leading coefficient. And the leading coefficient is the number in front of the variable with the biggest exponent. Our biggest exponent is x to the third. The number in front of it is -2. So -2x cubed plus 5x plus 8 is written in standard form. The degree is 3. The type is cubic. And the leading coefficient is -2. Questions on this here? Let's jump down to C. We'll do B here in a second. Yes. Yes. H of x equals -x squared plus 7x to the -1 plus 4x. So, we need to determine if it is a polynomial function. Exponents aren't negative. So we have a negative exponent, yes? So we can say this is what? Not a polynomial. It's not a polynomial. And that's it. Because again, it says decide whether the function is a polynomial function. If it is a polynomial function, then we need to write it in standard form, state the degree, type, and leading coefficient. It's not a polynomial function, so we're done. Because of that 7x to the -1, that x to the -1 power means it's not a polynomial function. Questions on C? Let's look at B. -0.8x to the third plus the square root of 2 times x to the fourth minus 12. Can we say that this is a polynomial function? Let's look through. So the first one, variables, exponents aren't negative, especially exponents attached to a variable. No, the only two exponents we have attached to variables are x to the third and x to the fourth. So that's fine. Other direction. Exponents aren't fractions. No, we don't have any exponents that are fractions, especially attached to variables. Do we have any variables in the exponents? Nope. So we're good there. Exponents aren't inside a radical. Do you have any variables inside radicals? It looks like we could. That square root of 2x to the fourth. But if we notice, the square root stops after the 2. If it had been extended out, if it went all the way over like this here, yes, the 2x to the fourth would be inside the radical. But It does not. We don't have variables being multiplied together. We do not have a variable in the bottom of a fraction. So this here is indeed a polynomial function. So, since it is a polynomial function, the first thing we need to do is write it in standard form. So which variable has the biggest exponent? 2 square root of 2x to the fourth. It has to go first. Then our x to the third would come second, so our negative 0.8x cubed. So we say minus 0.8x cubed. Our x squared term would come next, but since there's not one, we're not going to list it. Then our x term, which we don't have, followed by our constant. So, standard form for this here would be the square root of 2 times x to the fourth minus 0.8x cubed minus 12. So we're going to go x to the fourth, x to the third, x squared, x, constant term. We want that decreasing power from left to right. Now the degree would indeed be 4, because the degree is the variable or the exponent attached to the biggest variable. So 4 is our biggest exponent attached to a variable, so the degree is 4. Now our type would be I believe it's quartic. Quartic, quadratic would be 2. It does feel like it should be quadratic because quad is 4, but they've attached quadratics to our degree 2's. So quartic would be our degree 4. And lastly, leading coefficient. Square root of 2, because the leading coefficient is the number in front of the variable with the biggest exponent. X to the fourth is our variable with the biggest exponent. Number in front of it is the square root of 2. So the leading coefficient is the square root of 2. So D, we're saying it's not a polynomial because not a polynomial. 3 to the x, we cannot have a number to a variable. We can't have a variable to a variable exponent. So it's just not a polynomial. And that's it. We don't have to state degree, leading coefficient, type, write in standard form because it's not a polynomial. Questions on this here? Number 1, f of x equals 7 minus 1.6x squared minus 5x. Is this a polynomial function? Yes, we can go through that whole list of things, and it's not going to check any one of them. Well, it's going to make them all true. It doesn't have a negative exponent attached to a variable. We don't have a fraction as an exponent attached to any one of our variables. Variables are not inside of a radical. We don't have a variable in an exponent. We don't have the variable in the bottom of a fraction. So yes, it is a polynomial function. So the first thing we want to do is make sure it's written in standard form. So the first variable we should have is what? It's our, yes, negative 1.6x squared, our x squared term. Then we would have negative 5x plus 7. Because x squared term would go first, x, and then our constant term. Now the degree would be 2. Because the variable x squared is the variable with the biggest exponent, and that exponent is 2. Telling us the degree is 2. And since the degree is 2, our type is a quadratic. And negative 1.6. The leading coefficient would be negative 1.6. Yes. Negative 1.6x squared minus 5x plus 7 would be standard form. Degree is 2. Therefore, its type is a quadratic, telling us the leading coefficient is negative 1.6. Let's look at problem number 2. P of x equals x plus 2x to the negative 2 plus 9.5. Nope, not a polynomial function because negative 2. And it's not so much because of the negative 2, it is. We can't have x to the negative 2. We cannot have a negative exponent attached to a variable. If the negative 2, for whatever reason, had been attached to the 9.5, only that one has a negative exponent, that's fine. It cannot be attached to a variable. To a number, that's fine, whatever. But it cannot be attached to a variable. Because really what this is saying is that we have x plus 2 times 1 over x squared plus 9.5. Because to make that exponent positive, we have to move it from the top of the fraction to the bottom. Can't have a variable in the bottom of the fraction. It's going to be a polynomial function. Number 3, q of x equals x cubed minus 6x plus 3x to the fourth. Can we say this is a polynomial function? Yep, we go through that whole list of stuff that it cannot have, and it doesn't have any of it. So it is a polynomial function. Is it written in standard form? No. Three x to the fourth has to go first. That x to the fourth is the variable with the biggest exponent, so it has to go first. So our x to the fourth would be first, followed by x cubed, x squared, x constant term. Start with the variable with the biggest exponent and then decrease power from there. Telling us that we have 3x to the fourth plus x cubed minus 6x, and that's it. We don't have an x squared term. We don't have a constant term, and that's fine. But we do have these here. Now the degree would be 4. The type would be, would not be quadratic. I don't know why I started writing quadratic. It would be quartic. 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 And it would be 3. Leading coefficient would indeed be 3. Questions on determining if an equation is a polynomial, finding the degree, type, leading coefficient, and writing it in standard form. Pretty good with that there. We're ready for the next piece. Evaluate f of x equals 2x to the fourth minus 8x squared plus 5x minus 7 when x is 3. These should be the ones that y'all like to do if you're going to have to do them. These are the nice ones because when it says evaluate this equation when x is 3, all it is saying is take this equation and replace every x with 3. So all we're doing is replacing every x with 3. Whenever we plug a number in, we always want to put parentheses around it. So we're saying 2 times 3 to the fourth minus 8 times 3 squared plus 5 times 3 minus 7. And at this point here, I would just grab the calculator and let it do everything for us. So it's telling us that this should equal 98. That's it. Because we could do this by hand. We could say 2 times 3 to the fourth. That would be 2 times 81. 3 squared is 9. 5 times 3 is 15. Minus 7. 2 times 81. 162 minus 72, yes. 72. And 15 minus 7 is going to be 8. 162 minus 72 is going to be 90, and 90 plus 8 is 98, which we also got from the calculator. But most likely, we're going to end up, if we did it piece by piece, like I did just here by hand, you're going to type most of those pieces in the calculator as you do them. If you're typing each of the parts in, you might as well type the whole thing in all at once and let the calculator do it for us. Negative 2x to the fourth plus 6x cubed minus 3x plus 11. Negative 2 times 4 to the fourth plus 6 times 4 cubed minus 3 times 4 plus 11. Again, I would take that, type it in just as you see it, and let it do it for us. And I believe we get negative 129. Questions on this here? Questions on evaluating? Do you feel comfortable with evaluating? I don't think we need to see another example of evaluating these here. All right. Now the last thing we're going to look at is end behavior. End behavior of polynomial functions. What this tells us is what the function or how the function is going to react as we extend out to positive infinity and negative infinity. As we plug bigger and bigger numbers in, or smaller and smaller numbers into the function, how is it going to behave? And interestingly enough, it's going to behave in one of four ways, depending on two main pieces, the degree and the leading coefficient. So, degree. Now, if the degree is odd and the leading coefficient is positive, f of x is going to approach infinity as x approaches infinity. And f of x is going to approach negative infinity as x approaches negative infinity. So if the degree is odd and the leading coefficient is positive, that says as we plug bigger and bigger values of x in, the function is going to continue to go up. Doesn't matter what the degree is or what the leading coefficient is if the degree is odd. So 3, 6, 9, 12, 15, 19, and going on up, this is how it's going to behave, going left or right. It's just telling us how is the function going to end up doing going left or right. Now, in between, it can do all sorts of things. It can go up, down, but as we get big enough out, it's going to go up. It's going to increase towards infinity. As we plug smaller and smaller numbers in, it's going to eventually start going down. Odd degree functions are going to go in opposite directions. Now, if the degree is odd, and the leading coefficient is negative, if we're given that information, f of x approaches positive infinity as x approaches negative infinity, and f of x approaches negative infinity as x approaches positive infinity. They just go in opposite directions. It flips. So its leading coefficient is negative. As we plug bigger numbers in, it's going to go down. As we plug smaller numbers in, it'll eventually go up. There can be stuff in the middle, but eventually they're going to go in opposite directions. Even degree. If the degree is even, that tells us that the end behavior is going to go in the same direction. They're either both going to go up or they're both going to go down. That eventually, both ends of the function are going to go up or both ends of the function are going to go down. There can be a whole lot of up and down in the middle, but eventually they're both going to go up or they're both going to go down. So if the degree is even and the leading coefficient is positive, it tells us that the function f of x is going to approach infinity as x approaches negative infinity. And f of x is going to approach infinity, positive infinity, as x approaches positive infinity. With an even degree function, no matter how far we plug negative numbers in, the y value of the function is going to go up. Like our quadratics, our U-shaped graph, they either both ends went up or both ends went down. That's all it's telling us. So x to the fourth, x to the sixth, x to the 10th, x to the 200th. Eventually, both ends are going to go up or both ends are going to go down, depending on the leading coefficient. Now, if the degree is even and the leading coefficient's negative, both ends are going to go down, telling us that f of x is going to approach negative infinity as x approaches negative infinity, and f of x is going to approach negative infinity as x approaches positive infinity. All right. Now, how do we use this? Well, two main ways. One is going to tell us what we should expect the function to do, how it should behave, and that gives us a picture of our solutions or how it should look. So here, all we're doing so far is just describing end behavior. So when I look at this here, I want to know two things. I want to know what the degree is and the leading coefficient. So the degree is 4 because the variable with the biggest exponent is x to the fourth, so the degree is 4. Leading coefficient is negative 0.5. So the degree would be even, because 4 is even. And the leading coefficient is negative 0.5. So the leading coefficient is negative. Even and negative. So I look at my chart. Even and negative tells me f of x approaches negative infinity as x approaches negative infinity.
So asking this question, put
That. Yep. So it tells me the end behavior for this is f of x approaches negative infinity as x approaches negative infinity, and f of x approaches negative infinity as x approaches positive infinity. That's it. That's your answer. Because what that's telling me, what I should know from reading this or looking at this function, seeing that the degree is even and that the leading coefficient is negative, no matter what the graph shows me, I know that both ends of that function should go down. Should extend down at some point. And especially if we're graphing it, we're looking at the graph. And I see something like this here. This is not the exact graph. I just kind of sketched a picture. I know that both of the ends, the y value, should go down. That means, since I see in that little picture I sketched that it's going up as we're going to the right, or sorry, to the left, that means at some point it's going to have to come back down. Because both ends, end behavior says that it's going to go to a negative infinity to both sides. It's going to decrease, which means somewhere off this picture, it's going to come back down. F of x is going to negative infinity in both directions. It's going down. So f of x approaches negative infinity as x approaches negative infinity. And f of x, the y value, approaches negative infinity as x approaches infinity. As I go to the left and right, as x gets bigger and x gets smaller, the y value should both go down. They should both approach negative infinity. Degree. So degree is variable with the biggest exponent. X to the third is our biggest exponent. So the degree is 3. Leading coefficient is the number in front of the variable with the biggest exponent, so negative 0.3. Now 3, since our degree is 3, it would be considered an odd degree. Leading coefficient is negative 0.3, so it would be negative. Now, since the degree is odd, it tells us that the end behavior is going to go in opposite directions. It's either going to rise to the left, fall to the right, or fall to the right, rise to the left. It means that it's either going to be one of two shapes. So it'll either look something like this here, or something like this here. Because as I get smaller numbers, it's either going to go up or down, and vice versa going to the right. But as we look at odd and negative tells us that f of x approaches positive infinity as x approaches negative infinity. As the values of x, as I plug in smaller and smaller values of x, as it approaches negative infinity, the function itself should be going to infinity. It should be going up. In f of x, the function's value should be approaching negative infinity as x approaches positive infinity, which means our graph should end up doing something like this here. Questions on this so far? Yes, sir. Odd? So since the degree is 3, 3 is an odd number? Yep. Now, for the most part, why is this important? Why does this help us? It gives us an idea of what the graph should look like. What kind of zeros we should have, where it should be crossing the graph. Because again, we are going to be using the graphing calculators. Graphing calculators are going to help us, especially with solving. Because if I type this function in to the graphing calculator, and it tells me this here, it shows me in that 10 by 10 window, I have this here as my graph, or really 20 by 20. Well, it's odd, so they're going to have to go in opposite directions. Well, this here shows us that they're going both up, which means one of the two sides is going to have to go down. Well, I know that here, as f of x approaches infinity as x approaches negative infinity. As we go to the left, this function should eventually go up. It is indeed doing that, yes? Here it says f of x approaches negative infinity as x approaches infinity. So it's telling me probably at some point this right side is going to have to go back down. And again, when we graph, we look for zeros. We're looking for where it crosses the x-axis, for what values of x makes the function be 0. Which means I need to start looking somewhere to the right to find another 0. It gives us an idea of where it crosses the x-axis, where these solutions are. Let's look at one more. End behavior of this function here, 0.25x to the third minus x squared minus 1. So, the degree is 3, and the leading coefficient is 0.25. So the degree, with it being 3, the degree would be odd. Now, the leading coefficient, is it positive or negative? Positive. So since the degree is odd and the leading coefficient is positive, it tells us that f of x approaches infinity as x approaches infinity, positive infinity. And f of x approaches negative infinity as it approaches negative infinity. So it means our graph should look something like this here. Now what happens in the middle, depending on the degree how it looks, can change. But eventually, as we move to the right, it should go up. As we move to the left, it should go down. Yes? Yes, I probably have this flipped. F of x. So odd and positive. F of x approaches negative infinity as x approaches. Yeah, no, this is right. Now, the one that's on your paper and the one I wrote there, I switched odd and negative and even and positive. At least their positions on that graph. Does that make sense? Yes. So the homework I'm looking for is this. Did that answer your question of why that was negative, positive? Yeah. But that's it. 3 through 6. 3 through 6, decide whether the function is a polynomial function. If it's not, we just say not a polynomial. If it is, we need to write in standard form, state its degree, type, and leading coefficient. 9 through 14, 9 and 10. There is a problem. There is an error with how they wrote that. Either A, it is not a polynomial function, or B, it is, but they might have the degree, type, or leading coefficient mixed up. State what they did wrong and fix it. 17 and then 11 through 14, evaluate from the given value of x for the equation. 17, 18, 19, describe the end behavior of the graph. You do not have to graph it, but you do need the end behavior.